Okay, so this quick video is going to be about one of the ways we're going to factor quadratic expressions. So let's talk about those real quick. So the first method we'll use is using GCFs. That's what this video is going to be about, right? So we'll do that one. The next method is going to be using what I call fill in the blank. Now, this only applies to when A is equal to 1, and we'll talk about that in a later video. And then the more advanced way of doing it when A is not equal to 1 in standard form is what I call AC grouping. Okay, and we'll see that later on. But of course, like I said, we're talking about using GCF. So let's get into that here in a second. So right here, this is the example that I want. So I'm going to factor using GCFs. So all I'm basically going to do is look at all of the terms of this polynomial, right? In this case, this is the quadratic because it's a second degree polynomial, and factor out the GCF, right? So 5x squared, 40x, 75, these are all at least divisible by 5, meaning my GCF in this case is equal to 5. Okay, so what I'm going to do is I'm going to pull out a 5, right? And that's going to leave me with x squared plus 8x plus 15. Okay, now, what did I just do? Well, what I did was I did distribution backwards, right? If I distribute this 5 back in, right, it would become 5x squared plus 40x plus 75. It would become exactly the same thing that I started with, right? So all I'm doing is distribution in reverse when I'm factoring out the GCF. Okay, that's all this is. Okay, so let's look at another example. So let's look at the second example. Negative 4x squared plus 28x minus 48, right? If you were one of my students in my class, I would tell you we never want a negative leading coefficient just because it makes things complicated. If you can factor out the negative, let's go ahead and do that. And in this case, there's no reason not to. So I'm going to go ahead and say between these three terms, my GCF is going to be equal to negative 4. So that means I'm going to divide all three of these terms by negative 4 and effectively undistribute, right? Distribute backwards that negative 4. So then what I'm left with inside is x squared minus 7x plus 12, right? So I factored out my GCF, I did distribution backwards, and I can always check my work just to make sure I didn't do anything stupid. So negative 4 times x squared, negative 4x squared, positive 28x, negative 48. And it checks out. It gets me right back to where I started. Okay, let's do another one. It's right here, 8x squared plus 4x. Well, now I have a little bit more in common between terms, right? So 8, 4, well, I know they're both at least divisible by 4. But they also each have at least x to the first power. So my GCF is not only just 4, it's 4 times x, or 4x, right? So that means that's what I'm undistributing. That means what I'm pulling out of both of these terms, right? So this first term becomes 2x plus 1. And again, if I want to check my work, right, I can redistribute, and I would get 8x squared plus 4x. Right now, it's not necessary for you to sit there and redistribute over and over again. That's just something I'm doing to prove that, this is still an equivalent expression. Okay, and last one, we have 9x squared minus 2x. Okay, so 9 and 2 between them, can't do anything there except a 1. But they both have at least x to the first power. So that means my GCF is just x, and that leaves me inside the parentheses with the binomial of 9x minus 2. And if I did redistribute that, X times 9x, 9x squared, x times -2, -2x. And I've got it. So that does it for this video. That's how you factor out GCFs from quadratics. Pretty straightforward stuff. If you have any questions, shoot me an email. Otherwise, come see me. Goodbye.